You may be going to be writing math paper 2 on Monday or not, but this video may be helpful to you, so I'll allow for you to watch it to the end. Right, so in this video, we're going to be doing grade 12 analytical geometry. So this topic has 2 questions in this paper, and they are question 3 and question 4 respectively. Right, so in question 3, we're going to be dealing with everything that is involved with geometry, everything that we have learned since grade 4. So we're going to be dealing with the characteristics of quadrilaterals and the polygons. That means the rectangles, the rhombus, the rectangle. I don't know if I should have mentioned rectangles before, but let me actually repeat again. So the rectangles, the square, the rhombus, the trapezium, the parallelogram, and the kite. All of those quadrilaterals, the properties of them, we learned them from grade 4. We learned that the opposite sides of a rectangle are equal and parallel and stuff like that. All of those characteristics, you're going to be applying them in question 3 of analytical geometry. Right. And then you're also going to be applying things that are involved in geometry, like the inclination angle, the exterior angle of a triangle, the equilateral triangles, scaling triangles, like all of those characteristics of the polygons, the triangles, the hexagons and stuff like that. You know what I'm saying? Even though in grade 12 we don't actually deal with other polygons like the pentagons and the hexagons, we only deal with the quadrilaterals or the triangles, especially triangles, right? So all of those things that you have learned from grade 4 to grade 11, you're going to be, even in grade 12, you're going to be applying them in question 3 of this paper, right? And then question 4 is about the circle geometry. So we're going to be dealing with questions that are related to the equations of a circle, and the relationship of a radius of a circle and a tangent, the circle itself and the tangent, the relationship of the circles, like how the circles interact. So you're going to be given 2 circles, or you're going to need to imagine them, and then you're going to be answering questions that are in terms of the relation of the 2 circles, whether they touch once, they overlap, or they intersect twice, or they don't touch each other at all, right? So we're going to be dealing with questions like that in question 4. But in this video, we're going to be tackling questions that are of question 3 only, and maybe in a different video, I'm going to be tackling questions that are related to the circle geometry, which is question 4, right? So let us get into it, because I don't want to do no yapping at all. But I hope that now you know what to expect with analytical geometry grade 12, right? So we're going to be dealing with the characteristics of quadrilaterals, how the quadrilaterals relate with each other, the properties of them, the diagonals of them, the opposite angles are equal, the diagonals maybe bisect and stuff like that, right? And also the inclination angle, right? So do not forget about the exterior angle of a triangle. That is very, very important. So there's 2 properties that we'll have to actually put an emphasis on when it comes to analytical geometry. I'm going to name them down here, and you're going to need to note them down as well, right? So let us get into it. So this is a question from one of the past papers, and I'd love for us to go through it together. So that said, in the figure, L -4, 1, S 4, 5, and N -2 and -3 are the vertices of a triangle having SLN, the angle L 90 degrees, and then LN intersects the x-axis at K. So please allow me to draw the diagram and then continue to analyze the question. All right, so this is the diagram that I've been given. And before we get into the questions, I'll allow for us to go through an analysis of this diagram that I've been given. So we're also going to be applying, or we also need to take note of the characteristics of lines, like the co-interior angles, or maybe let me say the parallel lines, the perpendicular lines, the lines that intersect and stuff like that. So all of those lines, the characteristics of the lines, are going to give us characteristics of angles. Like parallel lines give us co-interior angles, they give us alternating angles, they give us corresponding angles, and then perpendicular lines give us right angles, right? So we also need to take note of stuff like that. And also parallel lines have the same gradient, the gradient is equal, and then perpendicular lines give us a product of the gradient of perpendicular lines give us a product of -1. So we need to take note of stuff like that. For example, let us say, or well, let me just say, we're going to need to take note of gradient of lines. Gradient of lines. We're also going to need to take note of perpendicular lines. Perpendicular lines and parallel lines. Parallel lines. I'll also mention the inclination angle. I also said one thing that is important, or well, 2 things that are important, which are the 2 characteristics that I want to put an emphasis on, are the following. So the first, so let me say NB. So the first thing is diagonals. So diagonals of a parallelogram. Diagonals of a parallelogram. When I say parallelogram, I'm also talking about square or rectangle. Or rectangle, what am I doing? Rectangle or rhombus. Okay, so if it's a parallelogram or square or rectangle or rhombus, the diagonals of those bisect each other. They bisect each other. Or we can say they share the same midpoint. They share the same midpoint. This characteristic is very, very important because it is common and it is applicable in a lot of questions that are in question 3 of analytical geometry paper, right? So what I'm talking about is the following. So maybe we have a rectangle. So the diagonals of a rectangle or a square or parallelogram or rhombus, they bisect each other. That means this line is going to be equal to that line, and this line is going to be equal to that line. Okay, so they share the same midpoint. So why am I mentioning this? It is because when you have something like this, when you have a parallelogram, a square, rhombus, or a rectangle, then you're going to apply that characteristics that the diagonals of those shapes, they bisect each other or they share the same midpoint. So that maybe if you have this point and we have this point, you're going to be able to determine the midpoint. And you're going to say maybe if you have this point as well, you're going to be able to determine that point. Maybe you have this point and this point and this point, but you don't have that one. So you're going to say the midpoint of this two is this one. And then you're going to be like the midpoint of this two is the same. And then you're going to be able to utilize that to find the coordinates of that other point. Okay, so this characteristics is very, very important. And then the other one is the exterior angle of a triangle. So the exterior angle of a triangle is equal to sum of two opposite interior angles. This thing we actually learned it in grade 9. Okay, so exterior angle of a triangle is equal to sum of two opposite interior angles. So that is something like if maybe we have a triangle, let me actually draw it here. Maybe we have a triangle, and then we have an exterior angle like this. This exterior angle that you see here, it is equal to the sum of this angle and that angle, not the one that is adjacent to it, only these two. Okay, so this angle is equal to that angle plus this angle. This also is one of the characteristics that is applicable in analytical geometry, question 3. Okay, so these two are very, very important. I want to put an emphasis on them because they're very, very common. For example, in this particular question here, we have a triangle. We don't have a quadrilateral. So the fact that we don't have a quadrilateral means that we're not going to apply this characteristic, but this one may be applicable because we have a triangle. So since we have a triangle, we may actually be required to apply this characteristic, which is that the exterior angle of a triangle is equal to sum of two opposite interior angles. Okay, so we need to be aware that this is something that we may actually be able, this is something that we may be required to apply. Right, I don't know why I'm stuttering when it comes to analytical geometry, but let us get into it because I don't want to waste any more time. This is our analysis, but before actually, this is not our analysis. This was me just pointing out the things that are important for us to take note of when it comes to this question. So let us do the analysis. So with the analysis, we have this triangle here, LN and S. So we can see that this triangle is right angled. So the fact that it is right angled means that we can determine its area. So area of triangle LNS is going to be equal to, because it is right angled, it's going to be half times base times height, but the base is going to be LN and the height is going to be LS, or the base is going to be LS and the height is going to be LN. The point is that we're going to say half multiplied by LN multiplied by LS. Therefore, we're going to need to find LN, the distance of LN, and the distance of LS, which are possible because we have the coordinate of L and N. We also have the coordinate of L and S. Therefore, we can actually find out the length of LS and the length of LN, and then substitute them here to find the area. So that is one thing that we have to expect to be asked in this question. It is possible for us to determine the area. And why did that cross my mind? It is because this triangle is a right-angled triangle, unlike in many analytical geometry diagrams that we are usually given. So this one is special because it's a right-angled triangle. The other thing that we can determine is the gradient of Ln, because we have both the coordinates of L and N. So we can determine the gradient of Ln. We can also determine the gradient of Ls. Okay, so we should actually expect to determine the gradient of Ls and the gradient of Ln. Right. The other thing that we should take note of in this question is the inclination angle. So this angle that you see here, this angle of theta here, it is an inclination angle of NS. I actually meant NS. Let me see, LS. Yeah, we can actually also determine the gradient of NS. Okay, right. So this inclination angle here, it is an inclination angle of NS. Therefore, we're going to need to find the gradient of NS for us to be able to determine the angle theta. Therefore, it is possible for us to determine the angle theta if we know the gradient of NS. This is us doing an analysis. We're not yet getting to the question, right? So we're going to be able to determine the gradient of the angle theta because we know we're going to be able to determine the gradient of NS. So we're going to say the tangent of this angle theta here, which is the inclination angle, it is equal to the gradient of NS. So since it is possible for us to calculate the gradient of NS, that means it is possible for us to find the angle theta. So these are things that we should actually expect to find or be asked in this question. So the gradient of LS, the gradient of LN, and the gradient of NS, and also the area of this triangle because it is a right angle triangle and we can find the length of Ln and the length of Ls, and also the inclination angle, which is the theta. It is possible for us to determine that, right? So inclination angle is an angle between a line N and the x-axis. So we can say that angle theta is an inclination angle because it's an angle between this line Ls and this line NS and the x-axis, right? So the other inclination angle here is the inclination angle here, which I'm going to call, because it doesn't have a name, I'm going to call it maybe let me call it alpha. Okay, so this inclination angle here, alpha, this inclination angle alpha here, we're going to need to find the gradient of LN to be able to find it. Okay, so it is related to the gradient of LN, because this angle, this inclination angle, it is between the line LN and the x-axis. Okay, so therefore we can say tangent of that alpha angle is equal to the gradient of LN. So far that means it is 1, 2, and then the gradient of this, which is 3, and then the area, which is 4. Those are the things that we're going to expect to be asked in this question. The other thing that we're going to need to take note of is the fact that we have a right angle. So remember what I said about right angles. So right angles are related to perpendicular lines. So it means that LN is perpendicular to LS. So LN is perpendicular to LS. So since these two lines are perpendicular, that means the gradient of LN, let me say NL is the same thing. So the gradient of LN or NL multiplied by the gradient of LS, they must give us -1. That is the characteristics of characteristic or property of perpendicular lines. So that is going to be number 5. Maybe just saying LN is perpendicular to LS, maybe it's going to be something else, number 6 or something, right? So 1, 2, 3, 4, 5, 6 are things that you're going to expect to be asked of in this question, all right? Right, so this is our analysis. So I hope that you actually understand this analysis here, and also what we're going to be required to apply in this question. Now let us get into the questions. So, oh my God, I'm going to need to go to the next page because I've already run out of the space. So what I'm going to do is I'm going to copy all of this into the next page and then continue to the questions after that. So I hope that now you understand what you're going to be dealing with in this question. Let me go to the next page. All right, so this is the diagram that we've been given, and I actually mentioned that we should actually expect the inclination angle of this angle theta here. And for us to be able to determine the angle theta, we're going to need to know the gradient of NS, that is that. And then number 2, I also talked about the inclination angle of LN. So this LN makes an inclination angle that I'm going to call alpha. You can call it any angle that you want, but I'm just going to call it alpha in this example. Right, therefore, to determine that angle alpha, we're going to say the tangent of angle alpha is equal to the gradient of LN. So we're going to read like it's equal to the gradient of LN. Therefore, we're going to need to find the gradient of NS and the gradient of LN, and that is that. Okay, so we're going to need to find the gradient of NS, LN, and also the LS. And then the other thing is that this is a right angle. Okay, so it's a right angle triangle. Therefore, LN is perpendicular to LS. The fact that these two lines are perpendicular means that the product of their gradients is equal to -1, which is going to be something that we're going to expect to apply. And also, we're going to find the area of this triangle LNS by saying it's going to be half base height, because it's right angle triangle. We're not going to utilize half AB cos of something. Half AB sine of C. We're not going to utilize that because it is possible for us to utilize it, but it is unnecessary because it is already right angled triangle, right? So we're just going to say half of LN times LS, right? And then that means we're going to need to find the length of LN. The length of LN, and it's possible because we have the coordinates of both the L and the N. And then to also find the coordinates, the length of LS, and it is possible because we both have the length of, the coordinates of L and S. Therefore, number 6 is going to be finding the distance or the length. I'm just going to call it the distance. So the distance of LN, the distance of LS, and the distance of NS. So these 6 things are things that you're going to need to expect to apply in this diagram here. I also mentioned that the characteristics that are important are of the diagonals of the 4 quadrilaterals, the rectangle, the parallelogram, the rhombus, and the square. I said that they share the same midpoint or they bisect each other. So since they share the midpoint, we're going to, like, maybe if we have a point here that is given and a point here that is given, and we don't actually have the coordinate of the center here or of this midpoint, and then maybe we have this point here, we're going to be able to find that point. We don't have this point here, and we don't have that point there, but we're going to be able to find this point by following the same procedure. So first of all, we're going to find the midpoint of the 2 points here. Okay, so we're going to find the midpoint utilizing the midpoint formula. So since they share the same midpoint, that means that midpoint that we'll have actually found utilizing these 2 points is going to be the same midpoint for these 2 points, or these 2 vertices, and then we're going to be able to find that other point by utilizing the midpoint formula again. Okay, so that is a question that is very, very common in analytical geometry. The second question that is very, very common is an equilateral, not equilateral triangle, exterior angle of a triangle. So this angle here, which is an exterior angle, it is equal to the sum of 2 opposite interior angles. So that is also the other character, one property that we're going to apply a lot in analytical geometry. And because here we have a triangle, we don't have a quadrilateral, we're most likely going to apply the second one than the first one. So this that you see here is my full analysis, and these are the questions that you're going to expect to be asked in this question. All right, so now that we have actually done this, let us get into the questions. So the first question is 3.1, of course. So it is saying calculate the length of SL. which is LS. Of course, we would have actually expected to be asked to determine the length of or the distance of LS or the SL, right? So since we have actually expected to determine that, let us actually just do that quickly. So we're going to be like 3.1. Because I'm not going to have enough space, I'm just going to write anywhere that space is available. So we're going to be like LS or the SL is equal to, the distance formula is there at the back of the paper or in the formula sheet. So we're going to be like the square root of, and then x2 or xl minus the x of s squared plus the yl minus the ys squared, and then that is going to be the square root of the whole thing. You're also welcome to say x2 minus x1 plus squared plus x y2 minus y1 squared. It is the same thing. And then they say we should actually leave the answer in set form. So if we have square root of something, we're just going to leave it as it is. We're not going to try to convert it to two decimal places. So you're going to be like the square root of, what is the x of l? The x of l is -4. So we're going to like -4. What is the x of s? The x of s is 4. So we're going to like -4, and then that squared plus the y of l is 1 here. So we're going to like 1 minus the y of s is 5, and then we're going to square that. So the square root of the whole thing. So what you're just going to do is press the whole thing to the calculator and determine what it is equal to. But because I don't actually have a calculator near me, I'm just going to do this manually. So -4 minus 4 is -8, and -80 squared is 64. So I have 64 here, plus 1 minus 5 is -4. -4 squared is 16. Therefore I have 64 plus 16. 64 plus 16, that's 80. Okay, so I have the square root of 80. So square root of 80, so I know that 80 is equal to 5 multiplied by 16. Therefore I'm going to have the square root of 16 multiplied by 5. Therefore square root of 16 multiplied by the square root of 5. Therefore 4, and then the root of 5. Therefore the answer here is 4 and root of 5 units. So please don't mind my drama about doing this thing manually. You're also just welcome to press the calculator. It's going to give you the same answer. That means SL is a distance of 4.5. 4 and root of 5 units. That is how we answer 3.1 and get our 2 marks. Let us go to the second question, 3.2. So 3.2 says calculate the gradient of Sn. Of course, we actually expect to calculate the gradient of Sn here. Right, so let us do that. So 3.2, the gradient of ns or sn. Okay, let me say sn is equal to, you have the gradient formula, you don't need to memorize it. So it's 2x y2 minus y1 over x2 minus x1, and then the y2, you also can say y of s minus y of n over x of s minus x of n is the same thing. So let me say maybe the coordinates of s are the 2 coordinates, and then the coordinates of n are the y are the 1 coordinate. So y2 is going to be y of s, which is 5, minus the y1 is y of n, which is -3. So 5 minus -3 over the x2 is the x of n, x of s, so 4 minus x1 is the x of n, and it is -2. So you're just welcome to press the calculator here. So the gradient of Sn is equal to, and I'm just going to do it manually. So 5 minus that's a plus, 5 plus 3 is 8, 4 minus that's a plus, 4 plus 2 is 6. So therefore I have 8 over 6, which is 4 over 3. Therefore I have 4 over 3, and that is the gradient of Ns. That is the gradient of Ns, right? Or Sn. So now that we are done with 3.2, let us get into 3.3. So 3.3 says calculate the size of theta, the angle of inclination of Sn. Of course, this is an angle of inclination because it is an angle between ns and the x-axis. So they want us to find its magnitude. So how to determine that? We're going to utilize this that I've said here. So we're going to the tangent of theta is equal to the gradient of ns. Fortunately, now we've already determined the gradient of Sn or ns. Therefore, it's going to be possible for us to determine the angle theta very easily. So it is only just 2 marks though. Let me actually write it here. 3.3. Let me see if you can actually see that. Okay, you can. So tangent of theta is equal to the gradient of ns or sn. So we're going to like tangent of theta is equal to, the gradient is 4 over 3, right? So we're going to like theta is equal to the tangent inverse of 4 over 3. Therefore theta is going to be equal to, and then we just press the calculator. So for this one, I'm going to need to press the calculator. So please excuse me for a second. So after pressing the calculator, I get 53.13 degrees. Therefore angle theta is 53.13 degrees. Right, let us get into the next question, which is 3.4. So question 3.4 says calculate the size of LNS. So the order is very important. They didn't say NLS. They didn't say LSN. Okay, so they said LNS. Therefore, they want the angle between L and S. They want the angle between LN and NS. Okay, so if they say L and S, they want the angle between LN and NS. So let us go LN and NS. So therefore it means that they want this angle here. This is the angle that they want. Because I've already assigned that angle theta, I'm going to assign this LNS angle beta. So I'm going to assign this one beta. So I have beta here, alpha there, and then theta here. All right, so order is very important. When they say L and S, they want angle N, and the angle N is going to be between LN and NS. So L N and NS. Therefore, they want this angle between these two lines here, which is this angle. So how are we going to be able to find this angle? So remember that I said we're going to either apply this property or this property. So because we have a triangle, we are most likely going to utilize this property, which is exactly the case. Okay, so for us to be able to determine this angle, there's no other way that we can be able to determine this angle unless we are able to find the area. So if we're able to find the area, maybe we are able to find the area, which is possible. So what we're going to do is we're going to find the area of this triangle. After finding the area of this triangle, we're going to be like, area is whatever that it is after finding it, and then say ln multiplied by ns of sine of beta. That is one way that we can actually find the angle beta. So that means we have two methods for determining the angle beta, and I'm going to do both of them. Let me repeat. So one way that we can determine the angle beta here is if, for example, we determine the area. Remember that I said for determining area, we're going to say area of ln s is half ln and ls. So right now we already have, let me see, SL. So we already have the LS, which is the SL, and it's 4 root of 5 units. We only need the length of LN. So we can actually be able to find the length of LN. After finding it, we're going to say half of LN multiplied by LS is the area. Then after finding the area, we're going to utilize the formula for calculate the area and say half LN LS then sine of beta, which is lns. Then of course we're going to have found the area already, so we're going to say this is equal to whatever the value of the area is. So you have the half, we have the ln, we have the ls, and beta is the only angle that is the only thing that's going to be an unknown, and we're going to be able to determine that. So that is the first method. The second method is utilizing this that I've actually talked about, which is the exterior angle of a triangle. So how do we determine that? So look at this. Look at this here. Okay, so that is exterior. This thing that you see here, this angle alpha here that I've actually assigned it myself, it is an exterior angle. So this exterior angle here, it is going to be equal to the sum of the two opposite interior angles. That means this angle beta here that we're going to need to find, and this angle here. Okay, so we're going to find beta by first determining alpha. Then after determining alpha, we're also going to need to find this angle here, which, because they are two vertical opposite angles, it is also equal to theta. So this angle here, it is theta because vertically opposite angles are equal. So if this is theta and it is equal to 53.13 degrees, therefore this one is also theta and it is 53.13 degrees. So now that we have the angle theta and its value, we're just going to need to find the angle alpha. And to find the angle alpha, we're going to utilize the quadrant of ln. Okay, so we're going to need to find the quadrant of ln. After finding the quadrant of ln, we're going to find the angle alpha. Then after finding the angle alpha, we're going to say angle alpha is equal to beta plus theta. Because we actually have the alpha and the theta, we're going to be able to find the beta. So there's two methods for determining the beta. The first method is the area method. The second method is the exterior angle of a triangle method. Okay, so we're going to do both of them. I'm going to start with, let me start with the exterior angle of a triangle first. Okay, it doesn't matter which one I start with, but I'm just going to start with the exterior angle of a triangle first. So let me actually shift my camera a little bit down so that you can be able to see this. So please keep this image in mind, but I'm going to draw it again anyway. Okay, so yeah, let me actually shift a little bit down so you can be able to see this. All right, so let me quickly just draw this equilateral triangle. Not equilateral, the exterior angle of a triangle. So I'm gonna have that. Come on, I'm gonna have that, and I'm gonna have this, and I'm gonna have that and this. This is what I have. So I have theta here, I have theta here, that equal, and then I have this angle beta, which I have assigned it, and then we have okay, well here we have k, but here we have l, and then here is n, and all the way up there is s. It doesn't matter, so we have s somewhere there, right? So it's l, n, and s. We're looking for this angle, which I'm going to call beta. So okay, here it's alpha, right? So we're going to be like alpha is equal to beta plus theta. This is what you're going to utilize because alpha is an exterior angle. Alpha is an exterior angle, and going to be like that exterior angle is equal to the sum of the two opposite interior angles. So already we have the theta, and it is 53.13 degrees. We only need the alpha to determine the beta. So let us determine the alpha. So for the alpha, we're going to be like, this is 3.4. So 3.4, we're going to be like tangent of alpha is equal to the inclination, what is it? The gradient of ln. So we're going to be like the gradient of ln. So we're going to need to find the gradient of ln. So I'm going to kill two birds with one stone. I'm not going to calculate the ln separately. So I'm not going to do this thing that you see here separately and then come to take it here or substitute here. So I'm going to kill two birds with one stone. So I'm going to be like tangent of alpha is equal to y2 minus y1 over x2 minus x1. But I'm not going to write it. I'm just going to substitute already. So I'm going to be like the y of l. The y of l is 1 minus the y of n. The y of n is -3. So I have -3. I know that the y of l is hidden. Yeah, it is hidden by the question, but it is already, you can actually tell that it is negative. It is 1, right? And then over the x of the x of l, the x of l is -4 minus the x of n, which is -2. And then from here, you're just going to press the calculator. So we're going to be like tangent of alpha is equal to 1 minus -3, it's 4. So you have 4 here over -4 minus minus. So that's a plus. So -4 plus 2 is -2. Therefore, we have -2 because 4 over -2 is -2. Therefore, we have tangent of alpha is equal to -2. And then to find the alpha, if if the angle is, I mean not angle, if the current is negative, for example, if the current is negative, then the inclination angle is going to be obtuse. Okay, that is one thing that I've actually taught my learners. I hope that you're going to learn that today in this video, right? So when the current is negative, so when the current is less than 0, the inclination angle is going to be obtuse. But when the current is positive, the inclination angle is going to be, when the current is positive, the inclination angle is going to be acute. Okay, it's going to be acute. And remember that all the obtuse angles are between 90 and 180 degrees. So they're between 90 and 180 degrees. Okay, right. So they are in the second quadrant. So obtuse angles are in the second quadrant. Since they're in the second quadrant in trigonometry is 180 degrees minus theta. Okay, so obtuse angles are in the second quadrant. So in the second quadrant, according to trigonometry, we have 180 minus theta. Okay, 180 minus theta. All right. And then in the acute angles are in the first quadrant. In the first quadrant, we have just theta. We don't actually need to say 180 minus theta, whatever the case may be. Okay, so that is the acute angles. But since here the quadrant is negative and it is negative 2, then we're going to have an obtuse angle. As you can see that it is actually an obtuse angle that alpha is. And then since it is an obtuse angle, that means it is in the second quadrant. Then we're going to say 180 minus theta. Okay, but here we don't actually have theta, we have the alpha. Okay, so we're going to be like 180 degrees minus then the tangent inverse, but we don't usually say the tangent inverse of negative 2. We say the tangent inverse of 2. This is something that you're going to do every time when you are dealing with inclination angles in the examination. When the quadrant is negative, the angle is obtuse. The angle being obtuse means that it is in the second quadrant. The fact that it is in the second quadrant, you're going to say 180 minus. I hope that is clear. But if the angle is, if the quadrant is positive, it means the angle is acute. The fact that the angle is acute means that it is in the first quadrant. In the first quadrant, we only have the theta, or we only have the angle as it is. Therefore, if it was positive 2, we wouldn't say 180 minus. If it was positive 2, for example, if it was tangent alpha is equal to positive 2, we'll just say alpha is equal to tangent inverse of 2. But since it is negative, it means that we have an obtuse angle, which is in the second quadrant. Therefore, we're going to say 180 minus tangent of 2. I know that certain learners did not know that, but now you do. Okay, so if it is obtuse, 180 minus. Or if the quadrant is negative, 180 minus. If the quadrant is positive, or if the angle is acute, then it is just that. It is not 180 minus. Right. So we're going to be like alpha is equal to 180 minus tangent inverse of 2. Alright, so let me just press the calculator and determine what the angle alpha is. Excuse me for a second. Alright, so after pressing into the calculator, I just found out that angle alpha is 116.57 degrees. Okay, now that we have angle alpha and we also have angle theta, we have alpha and theta, we can determine the beta, which is the angle LNS. So we're going to be like angle alpha is equal to angle beta plus angle theta. By the way, when you do these things, you should actually let them know that you have done this. So you're going to be like let LNS equal to beta. You don't just do this, okay? Because they don't know what beta is. So you have to make sure that you let them know. So you let them know that LNS is equal to beta, so that they know after determining beta, you have actually determined LNS. Don't just do this. You should let them know. So you're going to like let LNS equal to beta so that they know. And also, okay, we already know what the theta is, but you're going to say the angle LKX. So you're going to be like let angle LKX be alpha. How do I make alpha from this? Okay, let me just do this. Okay, so you're going to say let LNS be beta and let LKX be alpha, because we have L, we have K here, and then this is an x-axis. So you're going to like L, K, and then X. Or you're welcome to say LK and then O, because this point here is the origin, which is O. So you're welcome to say LKO or X, doesn't matter. LKO or X is alpha. You have to let them know that. Right, so angle alpha is 116.57 degrees, which is equal to beta, which we are looking for, plus angle alpha, which is angle beta, theta, which is 53.13 degrees. Therefore, beta is going to be equal to, we're going to take 53.13 to the left hand side, so it's going to become negative. So you're going to say 116.57 minus 53.13. I don't get the time to go to the calculator, so let me just do it manually. So I'm going to say 116.57 minus 53.13. So 7 minus 3 is 4, 5 minus 1 is 4, 6 minus 3 is 3, 11 minus 5 is 6. Therefore, beta is equal to 63.44 degrees. Okay, so that means beta is 63.44 degrees. But since we said LNS is beta, it means that angle LNS is equal to 63.44 degrees. So this is the angle that they were looking for, and this is how we found it and get our 3 marks. Okay, so this everything that we have done here, determining the angle alpha and also applying the the exterior angle of a triangle here is going to be 3 marks. But remember that this is paper 2, and for every statement you should provide a reason. We're not going to do that for the inclination, because inclination is a theory, it is something that you don't usually need to provide a reason for. But for this, you need to provide a reason. So you're going to say alpha is equal to beta plus theta and provide a reason. So the reason is going to be like an exterior angle. So you're going to say, let me write it here. You're going to say exterior angle of triangle is equal to sum of two opposite interior angles. So this is going to be your reason for saying alpha is equal to beta plus theta, okay? So you're going to say exterior angle of a triangle is equal to sum of two opposite interior angles, which we learned in grade 9. This is how you answer this question, and you're going to get 63.4 for the quiz S, angle LNS. That's the first method for determining it. Let us go to the next page to see how we're going to find the same answer utilizing the second method, which is the area method. So please excuse me for a second. I hope that so far you're still following though.